All right, now we're going to do this last part. We're going to determine the stretch at position 4 and clearly communicate your calculations. In other words, we're solving for the stretch. So we can solve for the stretch by using elastic energy equals 1/2 kd squared. So because we're in Google Sheets, it's going to look like this. So we're going to start with this equation. Okay. I know that my elastic energy at position 4 is 180 joules. So I'm just going to start to fill in the different variables, and then I'm going to work backwards to find out what stretches, because that's the easiest way. So 1/2, I know that my K, which is my spring constant, is, let's remind ourselves by scrolling up, it is 40. So go back down. 40 d squared, because I don't know what c is yet. So then now I can start to solve for things. So I want d squared by itself. So what I can do is I can divide both sides. So this is kind of awkward. I will do it like this. I'm going to divide both sides by 1/2. I'm going to do it like this so there's not so many parentheses, but this is going to look kind of crazy for a second. So what then happens is it cancels out on this side and it stays on this side because we need to solve for it, right? So 180 joules, 1/2 times 40 equals d squared. That's what I'm left with. Sorry, I forgot to break it up like this. Okay. So I have that, and then now I can start doing not that. So what I can turn this to get the exponent by itself is using the square root function. So I want to be able to square root. Let me see if I can do it in here. Nope, wrong button. I can. Oops. Square, but I can do a square root. And I realize, I'm so sorry, I should have been dividing. Oops, not fair. Dividing this whole time. Once again, I want to be able to square root, which then leaves me with square root. And if you're not able to do a square root, you can put SQRT for square root, which looks like squirt. SQRT also stands for square root, just to remind yourselves. So I'm left with square root of 180 divided by 1/2 times 40 equals d. Now I can solve for the distance. If I can type things in correctly, of course. Correctly, not incorrectly. All right, so I'm gonna do the math to break this down a little bit. 180, I'm not gonna touch yet, but I can do 1/2 times 40, which half of 40 is 20, okay, equals D. I'm just gonna break it down step by step so you can see. So then I have 180 divided by 20. I'm gonna use my calculator first just to make sure I'm doing it right, which gives me square root of 9 equals D. And then all I have to do now is square root of 9, which is 3, equals D. So my distance stretched would be 3. This would be my answer. So that is not formatted, so it wraps. So these are all of the different steps that I took. See if I can break it down like this for you. One. Well, I guess you can, well, your teacher have the examples as well. Let's make this one. So I did all of the little steps just so it would be very clear. So we're here, but essentially I started with elastic energy. I used the equation and I took it one step at a time until, till I was left with just square rooting. If you're not good at square roots, there is a button on the Desmos calculator that looks like the square root sign that I have. And put step 1. So, okay. So here are all of my different steps so that you can see it better. But basically, you want to be left with something as simple as this so that you can clearly figure out what the square root is. Something to think about if you want to do it mentally is what times what. So the same number times the same number gives you 9, which I know that 3 squared is 9. All right, that's how you do it.